Go on.
Hello everybody, my name is Alan Reedy, and in today's class we're going to be looking at the topic of roof and roof structures. Okay, here's a typical design of a nice featured roof, country design. We can see the slates, the coverings and the nice stone finish in the front. Okay. Now, the learning outcomes in today's lesson, learners will be able to identify the main functions of a roof, the difference between prefabricated trusses and a traditional cut roof, and also the function of the breather membrane and what coverings will go on the roof after it's pitched. I'm just going to hand out there's questionnaires here, so if you would like to take a questionnaire, take one and pass it on, and you can answer them throughout the presentation. Okay? Oh, perfect. So, the functional requirements of a roof. A roof must be able to provide shelter from the weather, provide thermal insulation, enhance the appearance of a building, and accommodate services such as drainage, water, electrical, and provide structural stability. We want the roof to tie in, it's a triangle, so we want to tie it into two walls and make everything rigid. And withstand all wind or all live, dead and wind loads, and including snow loads, especially winter time, the snow will be coming down, we have to incorporate that into our design as well. Now, so the functions of the roof: weather resistance, thermal insulation, stability, durability, drainage. We want to get rid of that water, the water pitch, so we need a good pitch, try and drain that water. Okay? Now, and here we have the different types of roofs. So we have our flat roof, we have our lean-to, the monopitch, the butterfly. These would be more typical to Europe, maybe Spain, France. You'd have the butterfly roofs, and then we have the hip roof, the common roof in Ireland. And here we have just a diagram of the typical roof terminology. So we have the common rafters here, and we have a valley rafter here with the jack rafters. Okay, and then we have the wall plates going around as well. Now, construction of roofs. Roofs come in two main parts. So we either have prefabricated trusses or we have cut roofs. Okay, so the difference is the prefabricated trusses are made off-site. They're made in a workshop, and they are usually made from gang plates, nail plates, and they're prefabricated inside a workshop, and then they're carried on site and craned up into the building and fixed in place. They're normally used in housing estates just because it's easier, it's more economical and more sustainable to use them. Whereas cut roofs would be more in a countryside setting, more of a one-off housing where the pitch roofs come into effect. Now, here we can see it, the diagram behind me, the prefabricated roof truss. As you can see, all the bracing, everything is triangulated. That's what we want to see. The strength is in a triangle, so that's just a typical example there. And yeah, if you can see that now, it's not great. You can see the gang plates, the nail plates, and all the joints. Okay. Now, as I said earlier, constructed in factories and assembled off-site, trusses are built jointed, tooted, galvanized steel plates, stop it from rusting. Any moisture prevents that. Bracing is placed lengthways and diagonally to stabilise the roof. So it's run lengthways and diagonally just to keep everything tied in. Now, and here's an example of our traditional cut roof. You'd often see this in a country setting. We have our dormer windows here, we have our fascia, we have our valleys, valley boards, and our jack rafters, and our gable ladders as well, tying everything in. There'll be straps in here as well to tie your gable ladders into your concrete block. Okay? Now, so the traditional cut roof, each element is individually cut. As I said, it is more economical in rural areas. The attic space is generally more accessible. And another point with the traditional cut roof, it's much easier to convert at a later stage than a truss roof. You're not supposed to cut a truss roof. They're engineered not to be touched, so it's definitely a better option if you're going converting your attic at a later stage to use a traditional cut roof. Yeah, the house design usually incorporates internal load-bearing wall, and as I said before, triangulation of roof members improves the structure. We're trying to get that triangle shape to improve and tie everything in together. Okay, I'll just touch on this, the roof covering. So, can anyone tell me what typical coverings would be on a roof in Ireland? What would we have?
Tiles.
Tiles, yeah, perfect.
Slates,
yeah, natural slates, yeah, perfect. Okay, galvanized sheeting as well. Okay, perfect. So here we have, you can see it there, the cross section. So we have our wall here, our outside wall. We have our soffit board, soffit lat, fascia board. We have our ventilation, very important. We want air to come in and circulate up here. We leave a space for the insulation, just to leave that air to come up. We have our battens here, and then we obviously start on our battens and then cover up, okay? And remember, we have the breather membrane is in here. The breather membrane is just over the rafter and underneath the battens, okay? So, as we're speaking, the underlay, the very first process of the roof covering is to get the underlay on, and excludes any rainwater, and it penetrates the roof or the tiles, and it's a breathable membrane. It means it allows the air to flow, but it doesn't allow the moisture to come in, okay? It's laid in the eaves first with a lower edge of 50 mil at the gutter, and row should be lap 150 mil minimum. The lap depends on whether you're using tiles or slates, it'll vary. And it's actually required now that you need a DPC lining just to run your first underlay, just to give it a bit of extra protection, okay? Now, and here's another cross section here. We can see our wall plate here, and we have our gable rafter. And you know, there's a nice fillet piece here. This is very important to stop so the water, if any water comes in, it'll run down here along your membrane. It stops the ponding, so your fillet piece will direct that water off. We want to get that water off as soon as possible. Okay, so I brought a little model in here today just to show you the principle of the actual roofing design. So here we have, I'll show you the cross section here. So here we have, there's our rafter, okay, and here we have our battens, 2, 3, 4, okay. There's our fillet piece, okay. So your underlay would go here on top of the fillet piece, and down here then into your gutter, okay. And there we have the slates, okay. So there's 3 holes in the slates. We have one, there's one under there for the 2 tacks, and we have a cramp pin here. The cramp pin is copper and it's pushed down and eventually oxidizes. You don't even see it afterwards, okay? It's usually made of copper, so it will oxidize. Now, so that's there's a lap here. This is very important now, this part, because there's a minimum requirement for the slates to overlap. So the minimum requirement from here, okay, from this point to the next point is 100 millimeters. We need 100 millimeters of an overlap, and that's to stop the water from coming back in, right, from here. So we want to get that water off the roof as fast as possible. Now, the only time it will change is if your pitch of your roof isn't steep enough. So if we have a lower pitch, something like a lean-to roof maybe, then it's recommended that you increase the lap from 100 mil to 125 mil, even more, 150 in places, okay? Depending on the roof, okay? Now, okay, I'll just put that aside. Does anyone have any questions? No? Okay, that's perfect. Right, now we talked about roof coverings. So tiles and slates can be placed into 1 of 4 categories: clay and concrete tiles, fibre cement slate, concrete slates, and natural slates. Okay. Here we have just an example of plain concrete tiles, fibre cement slates, and concrete tiles. You recognise them from home, yeah? Mm-hmm. Yeah. Installation, okay? So as I said, they're installed in courses, rows from the eaves. You start at the bottom and work up, and secured using nails through the holes provided, 2 pins and a cramp pin. Normally, because every second course, every second course only applies to tiles because of their weight, so you just nail every second course. Slates have to be nailed every course. And as I said, the head lap, minimum of 100 millimeters, can be up to 150 depending on the pitch, okay? Ridge tile is a tile, it's put on the ridge basically just as a capping to cover it. It's usually bedded in and a half round, and it's dyed mortar, bedded in with mortar, and then it's pointed in with dyed mortar just to blend in with the rest of the roof, okay? And here we have it here on the hip. So there's your ridge cap on your hip, and there it is on the main roof, okay? And here we have our valley. So this valley, we have our valley board under it, and then we have runs of lead, and then it's tiled in here. Okay, so we tile it in here, and there's a minimum of 100 mil left, and it should be done nice. And then it's pointed afterwards with mortar, okay? Stop any water from coming back in. And here we have it finished. No, nice and neat. As I said, that's just cut there now, that will have to be pointed afterwards. And it's always a good idea to turn up your lead, just in case you get heavy rain, and turn it up that way, okay? Now, roof ventilation, very important, very topical at the moment. So it's important, we want to vent our roof, we want to stop from mold and from dry rot especially. So ventilation removes water vapor, prevents condensation, okay? And here we have it's a cold surface meeting a warm surface, and that develops condensation, okay? Now, here's another sketch through. That's basically what I showed you earlier, just the model. And we can just see our roof vent. So we have the vent here on our soffit board. Air comes up, insulation is pushed back, and we want to get a nice flow, okay? Into your attic space, in between your battens, okay? And here you have it here, the roof vent and the soffit. Now, okay, we'll go back over our vision questions from earlier, okay? Okay, can anyone else answer me, list the 3 functional requirements of a roof?
To keep the weather out.
To keep the water out, yeah, weather.
To keep the heat in.
Heat in, what else? What else do we say about?